Welcome to the fascinating world of theoretical physics, where the boundaries of our understanding are constantly challenged. Today, we embark on an extraordinary journey into one of the most intriguing concepts in the cosmos: wormholes. Are they merely the stuff of science fiction, or could they hold the key to unlocking the mysteries of the universe? Let's explore this captivating topic together. From the silver screen to best-selling novels, wormholes have captivated our imagination for decades. These fascinating constructs serve as shortcuts through the vastness of space-time, allowing characters to traverse immense distances in an instant. Think of the dramatic escapes and thrilling adventures that unfold in these narratives. But as entertaining as they are in fiction, the real question remains: what does actual science have to say about these extraordinary phenomena? To understand the concept of wormholes, we must first explore the principles of Einstein's theory of relativity. Proposed in the early 20th century, this groundbreaking theory fundamentally transformed our comprehension of gravity and the very fabric of space-time. According to Einstein, massive objects, like stars and planets, warp the space around them, creating what we perceive as gravity. This bending of space-time is the essence of how the universe operates. Imagine a two-dimensional sheet stretched taut. This represents space-time. When a heavy object is placed on it, the sheet bends under the weight. In this analogy, the bending creates a dip in space-time, leading us to the possibility of shortcuts or wormholes. The idea suggests that, rather than moving across vast distances, one could theoretically take a shortcut through the very structure of space-time itself. This radical notion redefines our understanding of travel and distance in the universe, challenging the very nature of how we perceive reality. A wormhole, often referred to as an Einstein-Rosen bridge, is a hypothetical tunnel connecting two separate points in space-time. Picture it as a bridge between two distant islands. It could potentially allow for instantaneous travel between them. The implications of this concept are staggering. If wormholes exist, they could enable us to traverse the universe in ways we've only dreamed about. Imagine exploring distant galaxies, visiting exoplanets, or even reaching other dimensions, all made possible through the wonders of wormholes. However, while the mathematics underpinning wormholes is robust, several significant challenges remain. One of the most pressing issues is the requirement for exotic matter, hypothetical substances that possess negative energy density. This type of matter would be essential to counteract the immense gravitational forces trying to collapse a wormhole, thereby keeping it open for potential travel. Currently, exotic matter remains purely theoretical, with no experimental evidence confirming its existence. In fact, the concept of negative energy is one of the most perplexing aspects of modern physics. Some scientists speculate that if exotic matter were discovered, it could revolutionize our understanding of the universe, not just in terms of wormholes, but also in other areas of physics, like quantum mechanics. This quest for exotic matter might even lead to the development of new technologies, perhaps paving the way for advancements in energy generation or propulsion systems. Moreover, even if we were to overcome the hurdle of exotic matter, the question of how to safely traverse a wormhole presents another layer of complexity. Theoretical models suggest that the passage through a wormhole might not be a smooth ride. Extreme gravitational gradients could create hazardous conditions for any traveler. Imagine entering a tunnel that twists and turns unpredictably. One could encounter intense forces that would challenge the very limits of our technology and physiology. What might happen if a spacecraft tried to enter a wormhole? Theoretical physicists warn of potential hazards, such as intense gravitational forces that could spaghettify objects, stretching them into long, thin shapes akin to spaghetti. This phenomenon, known as tidal forces, could spell disaster for anything attempting to cross the threshold of a wormhole, raising both practical and ethical concerns about human exploration. How do we prepare for the unknown when navigating the vast and unpredictable landscape of space-time? Wormholes challenge our understanding of physics and the universe. While they are fascinating to think about, we must remain grounded in what we can observe and measure. Theoretical exploration is essential, but practical applications may still be far off. The allure of traveling through a wormhole is enticing, but we're still far from proving that they exist or can be utilized safely. Theoretical models may offer glimpses of possibility, but the reality is often more complex than fiction allows. Wormholes also raise captivating questions about time travel. If one end of a wormhole were moved at near-light speed, the phenomenon of time dilation could result in one end experiencing time at a different rate than the other. This invites speculation about paradoxes, such as the infamous grandfather paradox, where traveling back in time could potentially alter the past in unforeseen ways. Films like Interstellar brilliantly explore these themes, blending scientific principles with imaginative storytelling. They encourage us to ponder the implications of bending time and space. However, while such narratives fuel our curiosity, they often blur the lines between science and fiction, making it crucial to distinguish between what is scientifically plausible and what is pure imagination. As scientists continue to delve into the nature of wormholes, discussions about their implications extend beyond the realm of physics. Philosophers and theorists engage in debates about the fundamental nature of reality and the possibility of multiple universes. What would it mean for our understanding of causality if wormholes could indeed allow travel across time? The search for evidence of wormholes doesn't solely rely on theoretical physics. It also involves the use of advanced observational technologies. Telescopes and detectors capable of capturing the faintest signals from distant cosmic events could potentially provide clues about the existence of wormholes. For instance, gravitational waves, ripples in space-time caused by massive events like black hole mergers, might reveal hidden connections in the universe, hinting at the presence of wormholes. The implications of wormhole technology extend beyond travel. If we could harness the principles of wormholes, we might revolutionize communication, enabling instantaneous transmission of information across vast distances. Imagine a future where data could be sent instantaneously to any point in the universe, reshaping the way we think about connectivity and interaction. So, are wormholes merely fiction, or could they be a genuine possibility? The truth lies in a gray area. While the mathematics supporting wormholes is rooted in established physics, the practicalities of creating and traversing them remain elusive. As we continue to explore the universe and push the boundaries of our understanding, the future may reveal secrets we can only begin to imagine. The exploration of wormholes invites us to ponder the vastness of the cosmos and our place within it. Whether they remain a theoretical curiosity or evolve into a future reality, the quest to understand space-time is a journey worth embarking upon. Thank you for joining us in this exploration of the science of space-time wormholes. If you found this journey through the cosmos as fascinating as we do, be sure to subscribe for more insights into the wonders of our universe, where every question leads to new discoveries and every mystery beckons us to explore further.